Hello everyone. I'd like to welcome you to our talk today. We're going to be speaking about media extensions. My name is Richard Fricks. I'm a program manager on the scenario adoption team. And helping me today, I have Marcin Stakevich and Matthew Howard. Those are both developers in our Windows Media Platform team, and they're going to be demonstrating some code that illustrates some of the things that we're talking about. So I want to start just by putting this picture up. And if you were here earlier and listened to Todd's talk, I believe he started with this slide. He actually stole this slide from his deck. And I really liked it because it represents to me what media can be to an application. Media can take just a regular app and turn it into an awesome app. And as I looked at this picture when Todd went through his presentation, I saw emotion. Just visually, I see this guy grinning. And then I see this wonderment as this child's reaching up. Hey, listen to that sound coming out of that instrument. And then just the relationship you see there, too. And I thought, that is the neat thing that I really love about media, is that just the opportunity that you have through media to take an app and really turn it into something special. So in Windows 8, I feel like we've done a really good job in encapsulating the core media scenarios through our Windows RT APIs. But there's some scenarios that fall outside that core realm. And it's those scenarios where sometimes you need to turn to the media extensions for a solution. And many times when I'm speaking with partners about how to architect their solutions and I bring up this idea of a media extension, they kind of have a different picture in mind. And that's of this brick wall, and they just do not know where to go. So I want people to have this picture of the father with the guitar and the daughter sitting there. Oh, Dad, you're awesome, right? And not the brick wall. So how are we going to do that? So the agenda that we have for today, which its purpose is to kind of tear down that wall so you can understand what media extensions are and when you might possibly need to use them. So first I'm going to start by just giving an architectural overview of media as a whole in the Windows platform, because without that it's really hard to understand where media extensions fit in. So then we'll drill down deeper and get into the Media Foundation pipeline, because that is where media extensions live. And then through some demos, we're going to show how you can use Visual Studio 2012 to build some media extensions. Specifically, we're going to look at a media source, and Marcin's going to do that. And then we're going to look at how you can take and stream media from the Media Foundation pipeline and actually get that data up into a JavaScript application in case the application wants to actually be able to process some of that data. And Matthew will be doing that demonstration. So let's start just by looking at the media application architecture overall. And of course, up at the very top, that's the Windows Store app, and that's the piece that you're providing. And underneath that for media, if you're writing C#, we provide the media element. If you're using JavaScript, you've got the video tag and audio tag. And then also, whether you're writing in either of those languages, you have the Windows runtime. And through the Windows runtime, we have media namespace components, number one, for providing capture support for audio and video. For transcoding, if you have a file in format A and you needed to get it to format B, you can use the transcode object. Play2 for sending videos to DLNA-equipped televisions. The playback manager, which I believe Todd referenced earlier. And then what we'll be looking at today, the media extension manager. So when you write a Windows Store app, it's this level that you want to look at, the C# media element, the video tag, the audio tag, and the media namespace. And that's what you want to use to develop your app. The only time you would consider going lower than that is if you encounter a scenario that you see isn't going to work there. And that's when you consider using the media extension. So I just want to be clear. Do not go into developing your media app thinking, oh, I'm going to do media extensions. Because there's some work involved, and it's a complex process because there we go. So what we're going to look at here is the Media Foundation, and the name really describes what it is, and that is, it is the foundation upon which media is implemented in Windows 8. So all the APIs that are being called by an app, they're all funneling down and going into the Media Foundation, which is all native code. So if we drill in deeper and look at the components in Media Foundation, we'll see the pieces that make up this pipeline. First, there's the media source. And the job of the media source is to come up with this media data and put it into its independent streams. So if the media being played has a video stream, it needs to expose that. And if it has an audio stream, it needs to expose that. And then the pipeline comes together and puts all the components that need to come after to be able to properly render that stream. And you can see those laid out here. we allow each one of these pieces, the source, the decoder, an effect, an encoder, and a sync, to be replaced with a custom component that you can provide in your application. And whichever one you replace there, that's what we call an extension. So a media extension can be a source, it can be a decoder if you're providing a new stream type. It can be an effect if you're just trying to manipulate the data that's streaming through the pipeline. It can be an encoder, and then at the end of the pipeline, of course, is the sync. And the two most common ones, of course, are going to be the video renderer, which is the sync that displays the video up on the screen, and the audio renderer, which is taking audio and rendering it through the speakers. But if you had a situation where you wanted to do something different than that, then you could potentially replace that sync. So here's what's important to understand, though, because this is native code we're talking about, and a lot of Windows RT are thinking, hey, I can do C#, I can do JavaScript, I've got all these neat options. But if you're going to be writing a media extension, it has to be in C++. And that C++ needs to be built in its own DLL. And that DLL can be either just a straight native C++ DLL, or what we recommend is that you build it as using the new component extension build options, because it will make consuming the WinRT objects quite a bit easier. The other thing to realize is this DLL must ship in your app package, because this extension point is only available to apps that have the DLL in their app package. So when your app runs and you install this extension, other apps that are running on the system cannot access it. They will not be able to install it. If you create an extension that you want other developers to be able to use, you have to provide a mechanism for them to get that DLL so that they can include it in their own app package. When your app exits, that extension point goes away. And so it's unique to your running instance of your app. Also, inside that extension, of course, you can call any of the WinRT APIs. They're all available to you. But there are also some what we can now call desktop APIs that are available for you to use. Because when you're running inside of the Media Foundation pipeline, you have to be able to support some various COM APIs that are used by Media Foundation. So those particular APIs we marked so that they can be used in a Windows Store app. So when you're looking at MSDN documentation, you'll see with all of our APIs, you'll see applies to, and generally it says, hey, this is a desktop API, or it will say this is a Windows Store app API. But in some cases, you'll see it has both. And if you're writing a media extension, many times you'll be using some of the Media Foundation APIs that are marked as both. I included a link here as well that will take you to a list on MSDN that shows all the desktop media APIs that you can use inside of your application. And again, these APIs are specifically provided so that they can be used inside of a media extension. All the other scenarios, we have WinRT namespace objects to use. So they were specifically exposed just to allow for the media extensions to work well. So as far as how do you register these, I'll let Marcin and Matthew talk about writing them. But as far as you register them, the Media Extension Manager is the interface that you use inside of your application. And it has methods on it for registering the audio or video decoder that you've developed, or for registering the audio or video encoder that you've developed. But there's also this register scheme handler and register byte stream handler, which tends to cause confusion because people don't know what that means. So I'm not going to address that right now. I'll do that in a later slide so I can talk about it in a bit more detail. But let's take a look at the registering an effect. So an effect, you do not use the extension manager register because an effect is specifically applied to the element you're using. So if you have two media elements and you only want one of those to apply a special video effect to it, you would just use the add video effect method off the media element to add it, and the other one, if you don't call it, it'll display the video in a normal way. So for the media element and for our transcoder and media capture and the video and audio tag, they all have methods off of them to add an effect. And again, the reason for that is because an effect is only going to be applied to that specific instance of the element that you're using to render media, whereas when you use the media extension, that's global for your app. All the media elements are going to use that extension, and all the video and audio tags will use those extensions. So we've got those covered, and that leaves the sync. Now, we only support sync for capture. So if you're capturing video or capturing audio or both, you can write your own custom sync that will receive that data. And so the extension point for adding your sync there is off the media capture object, and they have the add sync APIs. So that leaves us the two remaining methods. And, of course, I don't have a check mark by media source, so obviously those two are going to be related. So both a scheme handler and a byte stream handler is what you write, and either of those components are what expose the media source. So, of course, the question then becomes, well, I want to provide this media source, so am I supposed to write a byte stream handler to expose the media source, or am I supposed to write a scheme handler to expose the media source? So if your media is in a container format that Windows doesn't support, but the container itself can be read, so in other words, let's say it's in a file, and of course we can read files. But we may not know how to parse that file because you've got your own custom container format. But if we can read the file, if our byte stream supports reading that file, it's just in a container format that we don't know how to understand, then you would generally write a byte stream handler. If your media is located somewhere that we can't read it, let's say your media is in a SQL database, or it's on a website that you access through some special protocol. It lives in some device that we don't support reading from, then you would write a scheme handler, and your scheme handler would expose the media source from it. So let's look at that in a little more detail just to help that make a bit more sense. So here is the interface that you would implement if you're writing a byte stream handler. And remember, the byte stream handler is a case where we do support reading the stream from the file, the byte stream, but we don't support the container format. So you've got pretty straightforward. There's just 4 methods there. The ones we're going to look at real carefully now is the begin create object. So there's some source code in C# using the media element. If you were to write that piece of code right there, a byte stream is going to get passed to your stream handler, and that byte stream has read and write commands off of it, and it'll stream the data to you from that file, leaving it now up to you to figure out how you're going to parse that container. And then you then pass back the media source object, and that's how the byte stream handler gets the media source put into the pipeline. Now let's look at the scheme handler. The same interfaces, it's got one less. We're going to focus on the same again, the begin create object. In this case, you've chosen this way because we don't have a byte stream that can read it. So we pass to you the actual string that was specified by the application. So up on that first parameter where the string is passed in, you're going to get that full string. And now it's up to your scheme handler to look at that string and figure out what that means. It could be a reference to a file on your web server, whatever data that you want to provide. And then once you look at that, you can then expose, you set the flag to say you're returning a media source, and then you return your media source. But a scheme handler also has the option of returning a byte stream. And you recall earlier I said that if we don't support the byte stream, you can write a byte stream handler. But in this case, a scheme handler will let you expose a byte stream, and I'll talk about that so you can understand how that fits in. But just to kind of redraw a picture here, we have the scheme handler that can expose a media source, the byte stream handler can expose a media source. In addition, though, the scheme handler can also expose a byte stream. A byte stream is just an interface that we've defined that is used to read streams from data. The ones that Microsoft provides in box, it lets you read a local file, lets you read from a network file, HTTP, blah, 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 to an MPEG file. We have a byte stream that can read that. But if you have data that, again, let's say it lives inside of a database that the system can't read, but the container format we support, you could potentially write a scheme handler. It exposes a byte stream. There's the interface for the byte stream. And that byte stream then gets passed back, and then we'll build the rest of the pipeline using all inbox components. So the inbox media source will use your byte stream to query for the data. All right, so here we have a more complete picture of the Media Foundation pipeline and how it works with media extensions. What I'd like to do next is we're going to focus specifically on a scheme handler exposing a media source. And to do that, Marcin is going to give us a demo. And here's the thing I want you to look for as he's going through this demos. The demos move quickly because we want to make sure we have time to get through all of this, but it's also very good stuff. So what you want to look for, number one, he'll be doing this in Visual Studio 2012, and it's being built as a component extension. He's using the Windows Runtime Library, WRL. That is what needs to be used to define the scheme handler interface. And then you'll see that his scheme handler is going to expose a media source. And he's going to use the property set feature to allow that media source that's sitting down in the Media Foundation pipeline, he's going to use that property set to be able to communicate to the application. So the application can actually talk and send information, and that information can go back and forth between the media source. And he'll show how you can do use property set change notifications. So if the app makes a change to a property, the media source will automatically be notified that the property has changed, so it can reread that value. And then he's also kind of had the extra bonus here of showing how you can use Direct 3D inside of a media source. That's very helpful. So with that, I'm going to go ahead and turn it over to Marcin.
Hello. My name is Marcin Stankiewicz, and I'm a developer on multimedia team. I'm going to show you today how to create a media extension, media source, and I will focus on communicating. So communicating between application and the media source. So let's get to my solution here. As you can see, it's a simple WWA application which uses geometric source extension. This extension is already available on MSDN as part of media extension sample. I updated it slightly, so this extension now is a C++ CX library. What's on MSDN is a native library, so here we've got it a little bit simpler. So let me get and show you how it works. Right. The geometric source is a very simple media source which generates frames on the fly. It simply draws geometric shapes on the frames and passes it up so they can be later displayed by the video tag, like that. We've got a square. Right? So let's get to implementation. So let's start with the scheme handler. So our scheme handler is implemented using WRL. Here I derive from runtime class. Here I tell WRL that my object is a WinRT classic com mix, which means that it's a WinRT object which implements classic com interfaces like our scheme handler here. Then I use inspectable class macro to help me implement iInspectable interface. The macro has two parameters. First one is full name of the class, and the second one is trust level. There is another macro I'm using, activatable class, which helps me to export our scheme handler outside so it can be activated from outside components. Yeah. Okay, here we've got our source. It's a standard implementation, very simple source which holds a pointer to one stream, so it's video only, so we've got only one video stream. Again, very simple. There is another class I would like to show you, which is a frame generator. It's my custom class which just simply draws shapes on the media samples. So what we can draw is a square, circle, or triangle. Very simple. So let's get to the application. So how we use this extension? So first of all, we need to reference it in our application. Here it is. Then we need to register the extension in our Apex manifest. That's a DLL name, full name of a class. So why we do it? Usually Visual Studio does it for us. If it finds a class in metadata exported from the library, it will insert this one automatically. But since we implemented our class using WRL and we don't provide IDL file, no metadata will be generated for this class. Hence, we have to do it manually. All right. So now, let me show you how we use the Media Extension Manager, which Richard told you about just a few minutes ago. So we create a new Media Extension Manager, and then we register our scheme handler here in line 18. So we pass, we call register scheme handler. We pass the full name of our class and the scheme under which it will be visible in MF environment. So from now on, every time MF sees an URL which starts with this scheme, it will initialize our geometric scheme handler, and we'll try to get a byte stream or a source from it. So here how we use it. So my scheme, full URL will be passed to our extension, and it's our extension jobs to interpret it. So it's a first example of communicating with it. We say we want a square. What if we want a circle? And our extension draws a circle. All right. So let's now move to property sets and communication with the extension via property sets. So I've got now my high-tech solution here in a notepad. Let me just update it a little bit. So if we go to our scheme handler and look at its implementation, so it implements iMedia extension interface. This interface has one single method, which is called setProperties, and it accepts a property set. Application can send configuration parameters via this property set to our extension. So let's now implement this. So let's say our source will receive these parameters and do something with them. So first of all, we need to add one more parameter to our create instance method. We're adding the property set here. Then we pass it to initialization method. So let's add one parameter here. We'll save it off into a variable. All right. And now let's go to implementation. So in CPP file, we have to do the same, change the signatures of our methods. Here, we pass the property set to initialize. Change the signature of initialize. Here, and remember the property set. Okay. If you go at the end, we've got a method called getColor. Now it returns a static color, which is red. We've got our GAB here and an alpha value. Let's instead retrieve the color from our property set. So we assume that application sends out color in under the color name. Our property set is a simple map which points from string to an object. So we'll retrieve this time a string, parse the string, and return a value of a color. The last thing we've got left to set up is to pass the property set from our scheme handler to our source. So again, we'll need a variable here. And we need to implement set properties. So if you noticed, our scheme handler is implemented in native C++ way. So we've got regular pointers. But it would be much handier for us to use C++ CX classes. So that's how we go from regular native pointer down to object, and then we can save cast it to a property set. And from now on, we will use C++ CX way of accessing property set. Okay. We need to pass property set to our source here. Okay, let's try if it compiles. Okay, great. Now let's move to application. So our application needs to create our property set like that. Then we will insert a color to it. So let's say our color is green. We insert it to our property set. And at the end, we pass this property set to our register scheme handler method. So what we do here is that we tell Media Foundation to every time when it initializes, when it creates a new extension, it should look for iMedia extension interface and call set properties on it and pass this property set to it. So that. Okay. Okay, and it's green. So far, so good. All right. So what if we would like to change properties on the fly? I mean, application is working, our extension is running, and we would like to switch from green to whatever else. So property set provides us with an event called map change. So if you hook up to this event, you will be informed every time when property set entry changes its value or it's get deleted or added. So then you can act upon that information. So let's move to my second scenario. So in our media source, in initialize method, we will add a new event handler to our property set. Like that. So here, we subscribe to map changed event, and our event handler has two parameters. First one is a map, which is our property set. The second one is arguments of the map change event. One interesting property on these arguments is a key. It tells us which entry in the property set has been changed. We are waiting only for color changes, and every time when color changes, we dynamically change the color on the stream. We need to synchronize the access to this event handler because it will be called on UI thread. So that. The second important thing when you use it is to unregister our event handler. It should be done in shutdown method. So why we use it? Why we do that? Because our property set may live longer than our media source. So if media source goes away, if it gets released, our property set may keep sending, we may keep triggering map changed events, and then we may get access violation exception, or we may corrupt memory if we try to do something in our event handler. So last thing we need here is map event registration token, which will help us unregister it. Right? Okay, now in the application I'll add a text box and a button. So we will enter a color value in a text box, and we'll trigger the change using the button. So text box, button. Okay. So yeah, in our event handler, in button click event handler, what I will do, I will get a value entered to our text box and pass it to our property set. This operation alone will trigger map change events, so then our extension will be informed about this fact. So that's what we do. Last thing to do is to hook up our event handler and initialize the color value with our default color. Let's run it. All right. Let's add some blue, and it works. All right. So this solution is not perfect. The problem here is that, first of all, we cannot call methods on our source. We cannot listen to custom events. We can only change properties, simple properties. The second problem is that this property set will be shared amongst all instances of our geometric scheme handler, which means if we would like to have two video tags with two different geometric shapes on the screen, we would be able only to change color both of them at the time, not we couldn't pick one or another. So for the Rust presentation, I will add some 3D support to our sample. So please bear with me, just add a few files. Like that. So, okay, great. Add to the file. So what I'm adding? The new frame generator. So for now, the frame generators were only producing two-dimensional images. And now I will use Direct 3D to render three-dimensional box and animate it in some way. So where I get 3D support? So 3D support is already provided by a pipeline. Our source is implemented in this way to utilize this acceleration. So if you see, I implement IMF Media Source X interface. This interface has a method called setD3DManager. So if pipeline is accelerated, it will provide us with with a pointer to this manager. From this pointer, we can extract a Direct 3D device, or we can do what I do here. We can use it to create a video sample allocator, which will help us to allocate media samples, which will live in graphics memory. Additionally, those samples will be reused, so we don't spend much time on allocating them. So those samples will be simply 3D textures. Okay. So now let's hook up our 3D frame generators. So let's go to the stream, include new frame generator header file, then add another case to our factory method here. So we're adding a box drawer. We need to add another enumeration to our source. Great, and now remember configuration object. So the new configuration object is just simple class which is supposed to be created by an application and passed to the extension via property set mechanism. And how our source configuration looks like. Okay. This is simple C++ CX class which has one event. So now our scheme handler, every time it will create a new source, it will raise this exception and inform application about it. And along with this exception event, and along with the event, it will send a media source proxy. So media source proxy is a way of communicating with our source. So we will be able to call methods, listen to events coming from the source, Plus, this media source has one-to-one relationship with the source. So with one media source proxy, you can control only one media source. So for our sample, our media source proxy looks very simple. So it's got only one property. I will be controlling direction of rotation, our box on the screen. Right. Okay. So let's now actually use our configuration object. So again, open. I will save the configuration to a variable, like that. Like previously, we looked up for a color. Now we look up the configuration, and remember in a variable. And in end open, when we actually know that everything went fine and our source can be successfully created, and return to MF, we inform about this fact the application, passing a proxy object to it. Okay. So now let's try to compile it. All right, it works. So now let's move to the application. Let's add 4 buttons to control the rotation of our box on the screen. Then in the JS file, we add source created event handler, which will then save our source proxy to a variable, and then we'll be able to use it for changing direction of the rotation. As I said, application has to create the configuration object. We'll do it in this way. So we just new it. Then listen to source-created events, and simply insert it, the configuration object, to our property set. Okay, let's just wire up the buttons. Okay. And change the circle to a box. And it rotates, and we still can change color. All right, so that would conclude my demo, and let's go back to Richard.
Thank you, Mark. Thank you. Okay, great. So next what we want to look at is, so Marcin showed us that media source from a scheme handler. He was dynamically generating frames on the fly, and he was communicating it from his application using property sets. First, he just passed down a simple property value, an integer for the color. And then he changed to actually pass down a class. So the class, he could call methods on the class, and that class was also down inside the media source. So he was able to define a much richer interface, since you can pass that a whole object back and forth using the property set. Now what Matthew's going to do, well, we're going to jump to the other end of the pipeline, and Matthew's going to show an audio sync. And the neat thing he's going to do there is this sync that's going to support audio. First of all, it's going to set up audio to capture uncompressed PCM audio. And then he's going to pass those audio buffers up into JavaScript. So he's going to show the technique for how to get the media streams that are going through the pipeline, how to get them up into a JavaScript app in a very efficient way that doesn't require copying buffers. And then he's going to write that from the JavaScript app. It's going to write that data out to a Wave PCM file. Okay, and go ahead, Matthew.
All right. Well, hey, everybody. My name is Matthew Howard. I'm a developer in the Windows Multimedia Platform team. How are you all doing today? So actually, I was just here for the Anonymous Functions Anonymous support group. I got lost. So, but in the short term that I've been programming on Windows 8, well, I guess I've been promising this and promising that too. So today, I'm going to demo to you a little bit more of the territory for media extensions. we have the ability to plug in a custom media sync into our capture API. And in this case, I'm going to take the multimedia samples that I get from the microphone, and as they're passed through the multimedia pipeline to my media sync, I'm going to then take those samples and send them off to JavaScript, show you that you can process the audio data in a JavaScript application. It also applies to C# and XAML. In this case, I'm using JavaScript. And then now that I've got that data available in my application, I'm free to record it to a file. You can also imagine scenarios where you might want to, for example, stream it to the cloud and do some speech recognition and then send results back to your app. So I'm going to show you how you can do that in Windows 8 today. I'm also going to discuss some techniques for efficiently passing that data because, as you can imagine, multimedia, there's a large amount of data that's flying around in real time. So how do you pass that from a native extension up into JavaScript without a bunch of buffer copies? And ideally, we like to reduce those copies. So let me describe my demo app really quick. It's just a simple JavaScript application. I've got an HTML5 canvas tag that's rendering the green background there. And let me start this listening. So as you can see, I'm already recording from my default microphone, and I'm just plotting the instantaneous waveform up into HTML5 canvas tag. And the audio samples have made it to JavaScript, and everything I'm doing in there is via JavaScript. I can also pass the data to our data writer API using the storage file and record that. And let's see, since it's Halloween, I thought I'd scare you all with my rendition of our national anthem, which I'm Ecuadorian, so of course I'll sing the Ecuadorian one. Salve patria, mil veces o patria. And then let's see if it actually works. So I pass the file name back to the audio tag. This is just a straightforward audio tag. Salve patria, mil veces o patria. And Ecuador is never going to let me sing that in public again, so thank you. All right, so now let's go into the code and see what makes an app like this work. To begin with, I want to talk about how to configure our multimedia media capture API so that we can record uncompressed audio. You can also record compressed AAC MP3, but in this case, I just wanted to demonstrate how you can process the uncompressed. And for this demo, I used mono PCM 16-bit. Again, you're free to change those settings. So inside my JavaScript application, when I started listening, clicked on the Start Listening button, I created a new instance of the Media Capture API in the Windows Media namespace. And I passed some initialization settings to it so that it'll use the default microphone. So in the init capture settings on line 141, I set it up to use the default audio device. And I tell it that I'm only interested in capturing audio. Now, obviously, if you're capturing video and audio, you'd use different settings. But, then for the Media Capture API, you can specify a custom sync to use. And this is where my media extension comes in. And in this case, I call it a sample grabber, because it's going to sit in the Media Foundation pipeline, and it's going to receive audio samples from the pipeline. In this case, uncompressed, but you could also have an encoder sitting in there and encode and grab those compressed samples out. My sample grabber, I'm going to pass it the audio settings that I'm interested in capturing so that it will only accept audio of that format. And it's the same settings that I used when I configure the Media Capture API. And then I add a sample available event handler on line 167 so that every time we have a new sample available in the pipeline, I fire that as an event back to the JavaScript application, and we process it from there. And I'll show you in a minute how I create the sample grabber object using C++ CX. So we're trying to do things a little. If you're familiar with the media extension samples on MSDN right now, all of them have an IDLE that you have to generate. They have a custom build step you have to use to merge the metadata back in. I'm going to show you a technique today that avoids that. You can just create your object using C++ CX. For that reason, I have this extra property off of the sample grabber, which returns the instance of the media sync. And then I pass that into the Media Capture API in the start record to custom sync async method. The profile that I used to capture to, there's just one quick note on that. The audio settings that I use, this is just a JavaScript object that defines all the media-specific format details that I'm interested in. The profile that I use to configure the media capture, I set it up to use PCM and all the settings like the number of channels and sampling rate and so forth. One thing I wanted to call out here is that if you're using your own custom sync and you're not recording to one of the inbox formats that would just archive to a file, you need to set the container to null. So on line 68, you'll see I set the container aspect of the encoding profile to null. Otherwise, it would expect a valid subtype for the container format. And I'm not interested in that. I just want to grab the samples and do something with them. All right, so the next thing I want to show you is that sample grabber object in C++ CX. So this is what it looks like. The sample grabber is a simple class. The constructor I passed in the IDU format just to make it easy. It has one property, line 24, that I use to return the instance of the media sync itself. And I'll show you that in a minute. And finally, that sample available property. The rest of the class is very simple. It's just for communication purposes. So in Marchin's sample, he already showed you how to use events to communicate, how to use the property set to communicate in two ways with the application. So I'm just going to extend on that a little bit by showing how to pass multimedia sample data up back into the application. The actual media sync itself, the interfaces for Media Foundation sync have been the same for a long time. So I'm not going to dig into a lot of details on how you actually write a media sync, although I will at least look over the interface really quickly. Let me begin with the media sync. So a media sync, since it is a native media extension, and it does require COM interfaces to communicate with our Media Foundation pipeline, we have to implement this as a WRL hybrid object. So again, I use the WRL WinRT classic COM mix, and the WinRT facing aspect of this implements the iMedia extension, and that again will allow me to get properties if I need it. The native COM facing portion of this class uses the COM Media Foundation IMF Media Sync and the clock state sync interfaces. This media sync, the interfaces, it's very straightforward. It has methods for accessing the stream syncs. There's a one-to-one mapping between streams and a stream sync. In this case, since I'm recording just audio, I've got one fixed audio stream sync. And finally, it has the ability to pass the data back up, and I'll show you that in 1 minute. The stream sync, again, I'll just show you the interface and then cover the important details of the implementation. One thing to mention with the stream sync is it's just a simple C++ class. There's no WRL required. There's no WinRT facing aspects of this class at all, so it's just straightforward C++. And what I didn't have to show you is the IDLE definition, because we don't have to use IDL since we use the C++ CX model to create the sample grabber class. And that's what JavaScript is going to create an instance of the sample grabber object and indirectly get access to our native media extension. That makes it a little simpler, I think. The stream sync interface, the important parts about it is it will get notified when the clock is starting. It has the ability to request samples, and then when Multimedia Foundation pipeline has delivered will deliver samples to it using the process sample method. And just to follow the sample data flow, Media Foundation will call process sample, and then I queue that up in the stream sync, and I pass it up to the media sync itself. You open up that file. And the process sample in the media sync is going to, this is where I actually take the IMF media sample, which is a native COM object, and I wrap it in a media sample object that is consumable by JavaScript. It's, again, a C++ CX object, and this is where this wrapper allows JavaScript to interact with the media sample itself and also the media buffer. So I'll show you that as soon as I'm done with the sample data flow. So I pass this to my sample grabber, and the sample grabber, the process sample simply calls that sample available event handler and to fire that event into JavaScript. So again, to follow the data flow, in my JavaScript application, the onSample event function will receive that sample as an event. I can get the sample as the event detail. In this case, I was also displaying the timestamp that we stamped that audio, the uncompressed audio frame with. And I can also access the buffer as a property off of the sample and then do something interesting with it. Now for this demo, I wanted to show how to save it off to a file. So I made my media buffer implement the iBuffer WinRT interface. And the nice thing about that is it allows me to not make a copy of the data, but just return an iBuffer that then I can use to pass into other native APIs that accept iBuffers, like the data writer, for example, or you can stream it off to the cloud. And then my scope visualizer, I also pass the same buffer to it so I can read the data out and plot it to the HTML5 canvas tag. So quickly to show what that buffer looks like, let me go to the media sample. I created two levels, one with the media sample, and then internally it has a buffer. For this demo, the media sample wasn't that useful, but in real-world scenarios, you'd want to get access to the timestamp, to other properties like discontinuity. For video, you'd want to know if it's a clean point, and so forth. So in this case, I show how to expose those sample attributes and sample flags, like the timestamp and so forth. This class also has the media buffer property, which just returns an instance of the buffer object. I'll show you that. That's where we return the actual data. All right, so first of all, I have a media buffer object, and if you look at this carefully, you'll see it doesn't actually do much. It has it implements iBuffer. iBuffer now only has capacity and length, which is great for telling the size of the data, but it doesn't actually give you access to the underlying bits. But this is the object as it will appear in JavaScript. So to avoid having to create an IDLE for my buffer using the interface definition language, I create just a simple class here with the same type as my real object. Now, when the compiler sees this, it will emit metadata that will allow my object to be consumed by JavaScript. So while this little object doesn't really do anything, it's not going to be instantiated directly. The JavaScript app receives an instance of the real media buffer on the event callback. The real media buffer object is below, and again, it is a hybrid object because it implements both the WinRT-facing iBuffer interface as well as a native COM interface, the iBuffer byte access. The iBuffer byte access is, I'll scroll down so you can see, it has a single method which returns the buffer as an actual byte array. So here's where I can give access to other APIs that know how to consume an iBuffer byte access, direct access to my multimedia data buffer without doing the copy. And again, to see how it's used after I pass the multimedia buffer back into JavaScript, if I pass it into my WAV file writer, which I use to just a simple example of how to write to a file, the write buffer API on line 44, you can see that I take the buffer as is and pass it directly into the data writer instance. And up above in the openasync function, you can see on line 35 where I create that instance of the data writer. So that's just a native not native. That's a WinRT API available that accepts iBuffers. So, excuse me. Now, I also showed how I was able to read actual audio samples and plot them onto the HTML5 canvas. And so I'll show you how that was done. Now, in this case, since I am actually reading I'm interested in reading through all the data, I make a copy of the array and I store it into just an array that I can access frequently as I render. Let me just open that up really quick to show you. So I created a simple waveform visualizer, and the process buffer function on line 48 also receives an instance of the buffer, and then it passes it to a function that copies it to an array. This is where I will allocate and I will make a copy. But if you could imagine that if you didn't want to also support iBuffer, you could implement something like iVector and implement the direct access if you wanted to avoid having to copy it. For the purposes of this sample, the iBuffer actually made more sense, so I stuck with that. Copying it to array was very easy. I used the WinRT Windows Storage Streams data reader. So I can pass the buffer to it, and then I can read from it. And in this case, I'm interested, since it's 16-bit unsigned audio, I want to read in 16s. And one other point I wanted to make is it bit me when I was working on this demo. Make sure you specify the byte order, because to make sure it's little endian. So, and with that, you can see the whole life cycle of the buffer as it is received by the media sync and passed into JavaScript for processing, and also some efficient data processing techniques. So with that, that concludes my portion of this demo. So thanks for your attention, and thanks for coming.
Thanks for going to press one in there. Okay, so I know we covered a lot of ground in those demos, and they really went through a lot of code, but we felt it was really important to pull that code together for you so that post this meeting, you can download that code and take a look at it and really see the nuts and bolts of how that functions. So one thing I want to point out is tomorrow at 4:15 in this room, we're going to have a question and answer session. So we've kind of dedicated a whole hour. If folks want to come in and share their media scenarios, we can kind of talk and kind of describe what the scenario would look like and maybe what some of the components are that you would need to use. So the media extension model is really about those situations when you need to do some custom processing on that media data, like was shown here, or you're trying to provide a new file format or a new codec support, those types of things. It's generally not something you would encounter just right in your core scenario type media applications. So some more media related sessions I want to make sure you're aware of. Later on this afternoon, technologies for building advanced media apps, and we'll be looking at the media player framework. So that's should be a very good talk for you to look into. And then tomorrow we'll be doing a case study where companies that have used the media extension model to provide some just really great functionality in their apps, they're going to be talking about how they used it and what type of scenarios they were able to implement through those features. And then, as I already mentioned, the Chalk Talk tomorrow. I put some resources on here that talk about the SDK samples that show how to use media extensions, the APIs that are available, more information on scheme handlers and byte stream handlers, and then just also some general resources. I think we still have a couple minutes now for questions. Look, we have about 4 or 5 minutes. So I do want to open up the floor. If you have a question about media extensions and how they might apply to your scenario, go ahead and raise your hand. If you want to go up to a mic and talk, yeah, go right ahead.
Can media extension be shared between Windows 8 and Windows Phone 8 applications? I can explain in more details. We implemented media stream source, custom media stream source for Silverlight for Windows Phone 7.
Yeah.
And with Windows Phone 8 using the same kernel and plans to develop application for Windows 8. Here's a question: if we can develop common components that can be shared between two models.
Sure. We won't be making any comments specifically about Windows Phone 8, but I will say the media stream source model, we do have an SDK sample for Windows 8 that implements a subset of the MSS interface, and it supports specifically streaming audio from the app down through the media pipeline using this extension model. But we talked earlier about how interfaces can be exposed from the media extension, and the media extension that we wrote in the SDK sample that you can download from MSDN exposes the MSS interface. And so that can be used to stream audio. I've seen that interface actually be updated to support video as well. And like I say, the SDK sample simply supports audio at this point. So my point being, though, is if you do have a MSS implementation and you would like to continue to leverage that model, I would encourage you to look at that sample in the SDK. Okay, any other questions? Yeah? Okay, so they're asking about the WMF format SDK and whether it's possible
so
to run.
the question is the WMF Windows format SDK available for a Windows Store application, and or if not, can you access the codecs? Right. So the answer there, unfortunately, is no. The format SDK is not available as a Windows Store app API, and the codecs are also not available, except for in a very, very small subset where we have an ACM wrapper built into the Media Foundation pipeline available. So we have support for, I think, GSM, support for, it's either ALA or EULA audio formats, but not in general.
Right. So in other words, you can't create an instance of one of the MF codecs and then be able to, interact with that directly. Okay, any other questions? We still have a minute or so feel free to raise your hand. Okay, so hey, thank you very much for coming. We're going to go over to Rainier. If any of you'd like to stop in and talk to us a bit further, please feel free to do so. We'll be over in there for about 30 minutes after this presentation. And hopefully we'll see you tomorrow as well for our Chalk Talk if you'd like to talk in more detail. All right, thank you.